So when we are adding and subtracting polynomials, we're going to start with here the adding and subtracting of monomials. What's a monomial again?
Number, a variable, or odd number, variable, whole number of exponents.
Okay, a number, or a variable, or a product of a number and a variable, and on that variable there can only be whole number exponents. Okay, so when we're working with monomials, first thing we're going to look for is we're going to identify like terms. We're going to rearrange, putting those like terms together. And as we're rearranging them, we're also going to think about standard form. And then we're going to combine like terms and see if we need to clean up our answer. Okay? So let's start with this first one. We have 2x squared plus 3x squared plus x. How many monomials? How many monomials? 3. Okay, could this be written in standard form? Could this be written in standard form? No. So if we're saying no, why not? What's the reasoning? Because we're adding. Oh, so when you're adding, you can't put it in standard form. What does standard form mean? What does standard form mean? Let's go back to that. What does standard form actually mean?
Putting like terms together?
No, that's what the definition of standard form was yesterday, putting like terms together. What was it? Chase, do you have yesterday's notes out?
Yeah.
Why don't you visit them? Because we're kind of needed some answers here. I need some help. Maybe you can come to the rescue.
Oh, I got it.
Austin.
With the terms and orders from greatest degree to least.
Okay, writing the terms in order from greatest to least degree. And then what did I say yesterday? This is not on your notes unless you wrote it. I said you can only write a polynomial in the standard form if what was that, Ken?
What?
What you're playing with over there? You can only write a polynomial in standard form if yes, that didn't stick. If there's only one variable involved.
Oh, yeah.
Remember that? Did I say that? But apparently you didn't write it down. Okay. Well, keep it in mind then. You better get it to stick. You can only really write a polynomial in standard form if there's one variable involved. So now I want you to look at number 1 and I want you to tell me, do you think we could write that in standard form? Is there only one variable involved? Yeah. So I'm thinking that we can. Could you right now, if I asked you to classify that polynomial, because it's a polynomial, is it not? If I asked you to classify that, could you classify it right now? What would you classify it as? Anything?
Binomial.
A linear binomial, okay? And it's linear what?
Because 2x squared and 3x squared can be added together.
Okay.
So like terms.
Okay, so but remember linear comes from what? Its degree name or its terms name? Its degree name. So that would mean, what's linear is the name for what degree?
It's quadratic.
Might be quadratic. Oh, and now it's binomial. Why is it only binomial?
Combines like terms.
So in other words, if right now we looked at it, we might be tempted to say it's degree 2, and it has 3 terms, right? So degree 2 would mean it's quadratic, and 3 terms would mean it's a trinomial. But Benton's right, because these guys are like terms, we can combine them. So if they have the same variable part, they're considered like terms. So if we have 2 of them and we add 3 more of them, how many do we have? Huh? Do you need your calculators? If we have 2 of them and we have 3 more of them to add to it, how many do we have? Oh my goodness. Can anything else be combined, added together? No. So we do have a 2-term polynomial now, which makes it binomial, and it is degree 2, which makes it quadratic. And is it in standard form? Okay, because it's degree 2, 1, 2 is bigger than 1. So notice what it says up here on the learning board. Not only can you add and subtract your polynomials, but here's the expectation. When it only has one variable involved, you're going to write the sums and the differences in standard form. So this is in standard form, is it not? So we're going to say standard form also. So not only is it the sum of our like terms, or our monomials, excuse me, it is the sum of our monomials. By combining like terms, we were able to say this is as good as we can get it. But we also have it in standard form. Okay, let's look at number 2. I want you to rearrange. I want you just to get in the habit of, even if it's eventually going to become mental math, in your notes especially today, I want you to show that we are going to rearrange this. And when I rearrange, I like to think of standard form right away. I like to put the terms at the beginning that are of the highest degree and group them there. So what should we start at the beginning with this one? What would our work show? What's the degree of this polynomial, first of all? 4. It's a degree 4, so we could probably just keep this 4z to the 4th, correct?
Yep.
Okay. Now, I'm going to do something that I feel like maybe I should do because there are some of you in here don't need this, but there are some of you in here who do. Before I even start rearranging, I'm going to make it into a total addition problem. So any subtraction I see, I'm going to just, first of all, change that to add the opposite. And there really was only that one subtraction. Because now, you know what, now we can just rearrange this, group them together, whatever we want, because it's all addition. So now I'm going to say, you know what, that 16z to the 4th can come over here with the 4z to the 4th. And my other two terms are constants. So they both are of the same degree. They're both degree 0, so put them together. And now I can say, what is my simplified, or my sum, of these monomials? What do you get? What do you get? So combining the z to the 4th, combining the constants, and now we would see this cleaned up in an answer bank as 20z to the 4th subtract 6. Is that in standard form? Can we even talk about standard form with this one? Can we talk about standard form with this one? Why not? Is there only one variable involved?
Yes.
It's just z's. So why can't we talk about standard form? We can. What's the name of this one? What would you call this polynomial? What's its classification? By the way, if I didn't impress upon you that you need to memorize these, I'm going to impress it upon you right now. Get them memorized. Benton.
It's like quartic binomial.
This is a quartic because it's degree 4, binomial because there's two terms. A quartic binomial. Okay, good job. Okay, how about number 3? How many variables involved this time? 2. Yeah, we have x's and we have y's. Are we going to be able to put this in the standard form? No. So then when algebra, here's algebra's kind of like little etiquette. When something can't be put in standard form, then they like like putting it in alphabetical order. I was going to use alphabetization, I couldn't say it. Then they like them to be in alphabetical order. So which one comes first in the alphabet? X's do. So let's, first of all, let's get all of our subtractions changed to add the opposite. And then let's rearrange according to the alphabet. X's come before y's. And both x terms are to the power of 3, so they get to be first, I guess. And the y's are both to the power of 3, and that's the only y's involved are those degree 3 ones. So we will group them together at the end of our, so we're just kind of like rearranging it at this point. And Avery, what's the sum of this one? I don't know. Probably the one we're working on. you get that, Avery? You just did. It just magically just popped right into your head, huh?
Yeah.
Do you have this book memorized or something? And I just didn't know that you had that photographic memory. What did you do? You had to do something up here. You should be able to explain to me what happened in those brain synapses. Okay, so what happens when you take 2x to the third plus negative x to the third? What happens? How does it go to x to the third? Does it just magically happen? Phew. It's 2 minus 1, or 2 plus a negative 1, right? Thank you. And 2 plus a negative 1 is 1, and 1x squared cubed is the same as x cubed. Oh my goodness, that kind of felt like pulling teeth. How about the y's? How do we get 6y cubed? How do we get 6y cubed? 7 minus 1, or 7 plus a negative 1. Is this done?
Sure it is.
Okay, is it in standard form?
Sure it is.
No, it can't be.
Never mind.
It's got more than one variable. It can't be in standard form. Is it in algebra etiquette form?
Sure it is.
Because x's come before y. So typically this is how we would see it in an answer bank. Okay, go ahead and do the last one on your own then. Apparently you've got this. You don't need me. You got this? Okay, Chase has put himself on the hot seat.
No.
Go for it, Chase. What is it?
I think it's M3, N2.
M3, N2.
No.
Did I not write it how we said it?
Yes.
M3, N2. I always love that. Huh. I think you meant something about some exponents, right? Okay, so M to the third. Oh, okay. Do you guys agree with him?
Yes.
Oh, okay. Chase, how did you get that?
Because 9 plus 5 is 14.
Oh, so those first two combined to become this.
13.
And then, of course, you did it all in one step and said, and then subtract 13, and you get 1. And do you need a 1 in front of it? No. Okay. We agreed? Is that what I heard? How come we could combine these? Why could we combine these monomial terms? What do you mean they're the same? What does that mean?
Same exponents.
Same exponents. Well, that can't be the only
And the
reason.
same variable.
And the same variables, the same exponents on the same variables, they match exactly their variable parts. That's why we can get away with it. Okay, let's go to the back side now.
Oh, I was back.
Adding polynomials. Know what it says. First bullet point. Parentheses are showing the polynomials being added. So we have in number 5, we have how many polynomials being added?
5.
No. 2. It says parentheses are showing the polynomials being added. So they're saying we have polynomial 4m squared plus 5 being added to polynomial m squared minus m plus 6. There's really only 2 polynomials here. One polynomial has 2 monomials, the other polynomial has 3 monomials. So yes, altogether, if we look at it that way, there are 5 monomials. But it's really important that we let them be their own separate polynomials, especially for subtraction tomorrow. So parentheses can just be dropped when it's addition. In other words, they're useless. Follow steps to add monomials. So we're going to just ditch those parentheses. And any subtraction we see, we're going to change to add the opposite so we can rearrange. The monomial of highest degree is what? So that would be the m squared. Am I supposed to read your minds? Okay, that's the m squared. So I'm gonna let all the m squareds come to the front of the line. What would be next in line? Are there any m's to the first power?
Sure.
Oh, okay. When I see a negative m, are there any others? Next in line? The constants. And the sum of our two polynomials is? Eddie? 5m squared. Okay, thank you. You're done. You're off the hook. Riley? Minus m. Hayden?
Plus 11.
Plus 11. 5m squared minus m plus 11. Now, is that able to be written in standard form? Why? One variable involved. Do we have it in standard form? Yeah, because what were we doing when we were rearranging it? We were taking care of it in standard form at that point, so our answer should end up in standard form, shouldn't it? Okay. Go ahead, you do the next one then. How many polynomials are being added? 2. Because there's addition between the two polynomials, we have permission to drop the parentheses. Big deal, come out and show your stuff. Finish this for me. Yeah, you're done.
Do it.
You didn't even do it. Well, then why are you just sitting there?
Because I'm thinking of what to do next.
Who's got this one for me? Because I'm not going to do it. You're going to. Help. Hurry up. We need some time to work and some homework. Waiting. Somebody come do the rearrange step. So the step you gotta do for me. I'll let you do that part. Rearrange step. Go for it, Lindsay. You're gonna have to be their savior. So they get some homework time here today. Maybe a couple minutes. Thanks, Lindsay. Now, after you do your rearrange step, it's always a really good idea that, because some of you kept wanting to say that there's more than 2 polynomials here. There really are only 2 polynomials to start with. But then, how many monomials were involved? 1, 2, 3, 4, 5, 6. After you rearrange it, you better still have 6. Okay? So, Colin, what's the final answer?
Well, okay. The third power was 15a, the second power minus 16a. Third power. No, it's 16a. Yeah, I was like, I didn't couldn't my brain.
Okay, you guys agree with Colin now that he's decided he can read and write better? Do you agree? Okay? I do too. Okay. This next one. Let's ditch the parentheses first of all because it's addition. This is what I'm talking about. It's addition. So we can ditch the parentheses. Can we have standard form involved here? No. So let me give you a little, indication of how algebra etiquette works with one like this. It has x's and it has y's. Which one comes first in the alphabet? X's. Well, then when they have both x's and y's in a monomial term, then you're going to be like, well, where does that one go then? Well, the one that, because x is with y, that one gets to be before that single y term. So we're going to start with an x here. Then we're going to go to those xy's. And then we're going to have that y be the end of our addition. That's kind of like how typically algebra etiquette would do it when you see it in an answer bank. So the x term doesn't have anything else to be combined with. Can these xy terms be combined? Can they be added together? So what does it become? 7xy. And then that y term at the end doesn't have anything to be combined with. So there's our final answer, our sum. And we can't say it's in standard form. All we can say is this is most likely how it would show up in an answer bank. Not always, but we're going to try really hard to get used to what we think it would look like in there. Okay. And last but not least, again, addition. So I can ditch the parentheses. And I can see that a lot of you don't worry about changing subtraction to add the opposite. And just hope it doesn't start getting us in trouble tomorrow. Okay? So the x squareds get to be first because that's the highest degree of any monomial term. The x to the first powers get to be next. Oh, I guess there's only one of those. And then our constants bring up the rear. We do not need a calculator for this. What is the answer?
16.9.
X squared, or to the second power, plus 5x,
Minus negative, minus 3, sorry.
plus a negative 3, which would be minus 3, wouldn't it? Yeah. Okay. Is that standard form?